Hello everyone, in today's After Effects scripting tutorial, we're going to be taking a look at how to create a script that will convert our scene to a 3D scene. Now this can either use a random algorithm to randomly place things in Z-space, or you can even use the Doppler effect. So first let's take a look at this cool example I put together using the script. So if you're not aware, the Doppler effect is basically when the wavelength of a wave changes, then it has different properties for the observer. So basically if a car is zooming past you, the sound is going to change because the waves are being compressed, like in this image. And the same goes for the universe. Galaxies that are far away and moving fast from us are going to be more red shifted, and anything closer is going to be more blue shifted. So this script is going to allow us to choose to use this Doppler effect, which will basically analyze how many red pixels, or the average red pixel frequency of any of these galaxies we have cut out. Then we can also use a cool function that I built in called center anchor points. And what this is going to do is if we say cut out our mask and our anchor points are all in the center here, this will automatically center them relatively to the center of their mask. And then of course we have a drop-down list for the background layer, whether or not we want the bottom layer or none to be the background layer. Alright, so the entire script itself is around 220-ish lines of code, but since that's a lot of code for a tutorial, we're going to be using this template here, which has all the functions and a couple basic lines of code to get us started. And that way we'll still go over how it all works, but we're going to be typing the more important code ourselves. So let's go ahead and quickly go over our UI here. It's called our 3D scene generator. We have our first group, which has a Doppler checkbox as well as a center or fix anchor point checkbox. These are just to keep track of what the user wants to do. And then in group 2, we have a background layer dropdown with none or bottom layer as the options. And then in group 3, we just have our generate button, which is going to execute everything. Then we go ahead and center and show our main window here so we can actually see our UI. And then I have two global variables set up. One is for the minimum distance and the other is for the max distance. So the way this is going to work is we're going to select a minimum z distance and a maximum z distance for that global variable. And if I were to actually run the script, we can see that it's going through and it's created two text layers as well as a scene camera. But what the script is actually doing in the background is it's analyzing every 4 pixels or so of each of these galaxy images we have cut out, and it's getting the R and the alpha values. And using this data, we can extrapolate where in Z-space our galaxy or our item should be. And we're going to build in some code to this algorithm when we use Doppler, so that in case if it returns an error, we're just going to randomize the Z position, and that should make up for any errors that it might cause. Because sometimes you can have, say, a massive galaxy and then a tiny galaxy, and if you're skipping every 4 pixels for the small galaxy, you might not get as many good data points to get the average red value. Alright, so now that our scene has been calculated, if we rotate the camera around here, you can see we have all of our stars here way in Z space, and if I zoom in using the camera tool, you can see we have all of them in different amounts of Z space. So our min distance is going to be the closest galaxies and the max distance is going to be the ones farthest away. So in this case I just have the min distance set to 0 and the max to 10,000 because I find as you sometimes get really high values, depending on your resolution can make it really difficult to navigate your scene. Especially when you have a large background and very small masks like this. And then we have an on-click function for our main generate button. And inside of here, we're first going to check, is there an active composition selected? If there's not, tell the user to do that. And then we're going to check if the number of layers in our composition is less than 2. And if it is, we want the user to add more layers. If not, what we want to do is go ahead and run our main function here. So I'll put in main, and the variables we want to pass through here are going to be our app.project and our active item, because now that we've done these checks, we know that it's a composition. For the second value, which is going to be our Doppler bool, we're just going to grab our Doppler checkbox and its value, which is going to be true if it's checked and false if it's not. We're also going to want to grab our fix anchor checkbox value, which again is going to be true or false. And then finally for our background index, which is going to be this selection here, we're going to grab our background layer drop down .selection.index. And that's going to give us just an int of 0 or 1 depending on what the user has selected. Alright, so now we're going to go into our main function here. We're bringing in our composition, our Doppler and anchor bools, and our background index. We're going to start off with a begin undo group, so that way this is basically where all of our other functions are going to be encapsulated, and we're going to start the scene generation right here so that we can undo everything in just a snap of our fingers. So the first thing I'm going to do is create a new variable called layer array, and I just want to get a variable. This is going to be an array, and it's going to contain all of the layers that we need to process. So any layer that's not the background that we need to either change the anchor point or find the Z position for. So our layer array is going to be equal to a function called getLayers, and this is going to be something we're about to set up, and we're going to pass through two variables, our composition and then our background index. We're going to need our composition to get access to all the layers we need to find, and the background index to omit that layer if we have it. And I like to set up all my functions in the main function first before I go and code those functions. So next up, we're going to have a function called generate camera, and we're going to send through our composition as an argument so we can add it to the composition. Pretty simple. And then we're going to do some checks. The first if statement check that we're going to do is to check the anchor point bool. So I'm going to say if our anchor bool, which remember is just equal to our checkbox we had, if the anchor bool is equal to true, which means the anchor point bool is checked, we want to center our anchor points. Then we're going to do a function called center anchor points. Then we're going to check if our Doppler bool, if Doppler bool is equal to false, then what we want to do is use a function called random positions. Else, if it's not false, the Doppler bool must be true. If it's true, we want to apply a Doppler shift effect. So we're going to make a function called Doppler Positions. And then that's going to be all of the functions we need to run everything here. I'm just going to make a note below layer array because we're going to be returning, again, an array of two values. The first index of the array, index 0, is going to contain all of our layers we need to modify. And then the second index, or the first index, is going to contain our background layer. If we don't have a background layer, it's just going to be null. So I'm just going to say the first index of our layer array is equal to our 3D layers, the ones we need to make 3D basically. And then the first index of our layer array is going to be our background layer. Alright, so the first thing we need to do now is go into our getLayers function, and we are bringing in our composition and our background index. Then we're setting up a couple of arrays and variables, one for our layers, and then those layers' name, and then for our background layer. The first thing we're going to do is set up our background layer variable, so we're going to call a switch statement which checks our background index. So if our background index is set to 0 or none, we're going to say our background layer is null. If it's case 1, our background layer is going to be equal to the composition and the layer with the index, the number of layers in our composition, which will basically only go and select the last layer here. And then the default, in case if none of these cases come true, is just to set the background layer to null. Then, like I said, since we had this node up here, we're going to have two indices with different values. We're going to return in the first indice all of our 3D layers, and then our background layer as a second one. But we don't have these variables full yet, just the background layer, so we need to get our 3D layers. For this, we're going to start with a for loop. We'll just say var I equals 1, and I is less than or equal to our composition and the num layers, the number of layers. Inside of here, I'm going to start with an if statement, and I'm going to say if our background layer is equal to null, so if they don't have a background layer, we're basically going to go through and grab every single layer in the composition. So we're going to say 3D layers.push comp.layer I. I'm also going to push into our 3D layer names, the same thing except the name, obviously. So comp.layer I.name. And then our other statement that we need in this for loop is going to say if our background layer is not null, so let's say they selected the bottom layer and they want a background layer, and so if our background layer is not null and I is not equal to the number of layers in our composition, then we're going to push the same things into our 3D layers. So basically when this runs through, it's not going to switch on the same execution which one of these if statements it goes into. If they have none selected, it's going to go through this one every time. If they have bottom layer selected, it's going to go through this one every time. And this will just make it so that we get the proper layer array for future processing. Alright, the next function we need to go over is generate camera. If we go down here, I already have the code set up for it because it's really simple. We're just going to reference our composition, the layers inside of it, and we're going to use the function called add camera, which is built in. And the parameters that it takes is going to be the name of our camera, which we're just going to call 3D scene camera, and then also a 2D array of the center focus point. So for this, I'm just choosing the very center of our composition. Alright, next up we need to go ahead and center our anchor points if we've selected that. If we go down to center anchor points, we've got a bit of code to write. What we're going to do is basically just run through our layers array we're bringing in. And I should also update our functions here because now our layer array actually contains these values. So when we call center anchor points, I want to pass through the layer array index 0, which is our 3D layers, which we're going to be fixing. We don't need to fix our background layers anchor point, just our 3D layers. For random positions, we're going to say layer array index 0 and layer array index 1. We could just send through the whole variable, but I want to be able to split them before they go into the function here. And then I'm going to copy and paste these two layer arrays here indexes and also add comp to the end of it. Alright, so back inside of our center anchor points, we now have our layers properly coming through. We're going to set up another for loop, say var I equals 0, I is less than our layers.length, increment I by 1. Then we're going to set up a variable called this position. This is just to get the current position of the current layer we're going through here. And we're going to set this equal to calculate position. And we're going to pass through our layers here and the current layer, which is going to be index I. And again, we're going to set up this function here right below as soon as we're done up in here. Then we're going to check if this position value 3 is equal to true. Then we want to grab our current layer, which is layers I. We want to grab the position property and we want to set the value. And then I'm also going to grab the layer again, and this time I'm going to grab the anchor point property and set that value. Now if we go down here, you can see it says this position index 3. This position is going to be equal to whatever our calculate position function returns. If we look down here at our calculate position function, we return 0, 1, 2, 3 values. So this is just going to be equal to our mask bool, which we'll go over in just a minute. Actually, let's go over this now because we now need to set up our calculate position function. So first thing, we're going to set up a variable called mask bool. This is going to keep track of whether the layer has a mask. For example, if we have a null object or some kind of layer type that doesn't allow you to have masks, this is going to filter those out so we don't have any issues when we're applying anchor points or Z positions. First, we're going to check if our layer has the masks property and a mask 1. So if you have mask 2, for example, this isn't going to work. But we're going to be checking for mask 1 because we just have simple outlines of galaxies here. If it's not null, so if it does have masks in this mask, we're going to say the mask bool is now true. We're going to set up this path to be equal to our mask path, and this is going to reference the entire shape of our mask. Then we're going to have a variable called numverts, the number of vertices, and this is going to be equal to our mask path, this path, the value, and the number of vertices. So this would be 1, 2, 3, 4, 5, 6, 7, 8 would be our numverts. Then we're going to set up two arrays, one called vert array X and one called vert array Y.
Why, Lisa? Why, Lisa? Please talk to me, please!
So below our arrays we've defined here, let's go ahead and calculate these positions. We'll create a for loop, and we'll say var I is equal to 0, and we'll say I is less than our numverts, and we want to divide this by 2, and then increment I by 1. The reason we want to divide this by 2 is because our numverts is going to use an X and a Y coordinate, and we just want to grab both of those at the same time. So inside of here, we're going to say vert array X dot push and vert array Y dot push. And what we want to push is going to be this path, its value, and then inside of the vertices here, we want to grab index I and then 0. And same thing below, we're going to copy and paste this path value, vertices index I, index 1, because this is going to reference the first pair of vertices, and then the second pair, etc., and we want to grab 0 and 1 to get X and Y. Then we're going to define a quick little sort function, so vert array X dot sort, and inside of here we'll say function A comma B, and we want to return A minus B. Close that bracket, and I'll copy and paste that for our Y array as well. And what this is going to do is basically make it go from the smallest value up to the highest value. The reason we're doing this is so we can grab the first value and say that's our low value, and then grab the last value of the array and say that's our high. Then we can take our X, divide it by 2 and average it out, and same with the Y. And then what this will do is give us a rough estimate of the center point of our area here, of our shape. So we're basically going to say, grab an array of all the X and Y positions of these vertices, sort them from lowest to greatest, and then we're going to grab, say, this has the lowest X value here, it's furthest to the left. It's going to grab the lowest X and the highest X, grab the average, and set the position to be there. Same with the Y, it's going to grab both the low and the high one and set it in the center. So to do this, we're going to say var calculated X, var calculated Y. For our X, we're going to say our vert array X index 0 plus our vert array X, and then we're going to grab the length of our vert array X. Like I said, we need to grab the amount of elements inside of it, so like that. And then we're going to divide all that by 2 to get the average. And again, I'll just copy and paste that for down here. Change this to Y, grab the first index, which is the lowest Y value, and grab the last index, which is the highest, add them together and divide them by 2 to get the average. Now we need one more variable here called factor. The original Hubble image that I used for this was, I think, around 6,000 by 6,000, but this composition is 2,000 by 2,000, so any of the positions we apply need to be factored to accommodate for any large scale increases or decreases. So our factor amount is going to be equal to app.project.active_item, so our composition, and the width of our composition, divided by our layer.sourceRect@time dot width, and inside of our sourceRect@time method, we're going to say 0 and false. So what this is going to do is take the current composition's width, which is 2,000. It's going to divide it by our layer, the current layer's size at the time 0 in its width, so which would be 6,000 because that's the original size of the layer. So if I take 2,000 divided by roughly 6,000, we're going to get about 33% or 1/3. So when we return our calculated X, which is supposed to be the middle X of our mask here, we need to multiply it by our factor, because otherwise it's going to be way off in the distance because our scale would be off. Now if you didn't change scale, if my original image was 2,000 by 2,000 pixels and my current image is the same, our factor would simply just be 1. So then our calculated x would not change. So this is just a nice little thing to make sure this is going to work for every size image and every size composition. So we're going to return our calculated x times our factor, our calculated y times our factor, 1 divided by our factor, which is the reciprocal, which we're going to need a bit later on, and then our mask bool. So now if we go back up to our center anchor points, we can now use our this position variable here to set our position and anchor point values. For position, what we're going to do is say this position index 0 and this position index 1. So this is going to bring back our x and y and set that as the position. And then for our anchor point, we're going to set it to this position index 0 times this position index 2, and then this position index 1 times this position index 2. The reason we're going to do this is we're going to take our calculated x position, multiply it by the reciprocal of our, and then for our y, we're going to take the calculated y and multiply that again by the reciprocal of our factor. Alright, so now if we scroll back up to our main function, we've done the get layers, we've done our generate camera, we've done our center anchor points. Now we need to set up our random or Doppler positions. So for random positions, we're going to be bringing in our layers and our background layer. And if we go down here to our random position functions, we can go ahead and get started here. The first thing I'm going to do is call a for loop so we can go through all of our layers. So I'll say var I is equal to 0, I is less than our layers.length, and then increment I by 1. We'll set a variable called this position inside of here, and set this equal to the current layer we're going through, and the property position, and the value of that. Then we're going to want to turn on the 3D switch for this layer. So I'll grab my layer and say .3D layer equals true. And that will basically just turn on the 3D switch for my layer. Then I'm going to set our layer position. This is going to actually set the position for us. So I'll say the current layer, property position, and we're going to set the value. And because it's now 3D, we need 3 values, x, y, and z. The first one, we're just going to say this position index 0, which is our default position here. And this position 1 for the default y. And then for the z, since we're just going to be randomizing this, we're going to say math.floor, so we want to round a number. And inside of here, we want to say math.random. We want to multiply that by our max distance plus our min distance. So what this will do is basically round up a random number between our minimum distance and our maximum distance that we have set up right here. Then we also need to take into account they might have a background layer. So I'm going to say if the background layer is not equal to null, so it exists, then what we want to do is first check if our background layer dropdown, if the selection index they've made is equal to 1, which means it's the bottom layer that they want to be the background. Then we need to grab our background layer, grab its property of scale, and we're going to want to scale it up quite a bit by setting the value. And the reason we want to do this is because we're going to be pushing it way off into Z space, so we need it to be the proper scale. So we'll just say 750 by 750 for that. Should be good, but you might have to compensate depending on the size of your background layer. And then we're going to grab our background layer again, and we're going to say 3D layer equals true. Then outside of this second if statement for the background index, still inside of our background layer is not null if statement, we're going to grab our background layer and set the position. So I'll grab the property called position and set its value. And I'm going to want to set its value to, again, 3 things. The first one is going to be our background layer property position and the 0th index value, which is our x. It's very similar to what we did right here with this position. And then for our y, we'll say our background layer dot property position value index 1, and then max distance for our z. Alright, so now that we've finished up our random positions, we need to go ahead and do our Doppler positions. So if the user selects use Doppler for Z position, we need to basically analyze each one of our layers here. We need to go through pixel by pixel or every few pixels and see what kind of red and alpha values we can get. The reason we're going to check for alpha values is if we're outside of the mask, we don't want to use that data. So we're going to check if the alpha is applied or not. And we're also going to use another text layer to read the red so we can get the actual Doppler shift. So inside of our Doppler positions function, we're bringing in our layers, our background layer, and our composition. We're creating a couple of variables, one called these bounds.
These nuts.
Which are going to be all the bounds of each of these vertices for each of the images. Then one called shift, which is going to be the amount of shift. Our current layer, which is going to be the layer we're currently going through in our layers array. A point control to control where we're analyzing our pixels. The point, which is to fix where the point control is looking. And our OG position, or the original position, is going to be our old position, and that's just so we can get our X and Y position and easily change it. And then we're also just gonna say 0 is our min distance and 255 is our max distance for our red values. So we'll start off by making a for loop that will run through all of our layers. So we'll say var I is equal to 0 for I is less than our layers.length. We want to increment I by 1. And then we'll set our current layer variable equal to the current layer we're on. And now we're going to want to create our alpha reading text and our red reading text. So I'll say var alpha text, var alpha source text, and then I'll also say var red text and var red source text. So for our alpha text, we're just going to grab our composition, go into the layers, and we're going to add some text. For the alpha source text, we're going to reference our alpha text, and we want the value source text. So property source text, and this is just going to grab the information that you basically type into the text. And then for red text, we're going to do the same thing, comp.layers.add text, and then for the red source text, we'll take our red text and the property source text. Alright, and then below this we need to set up an expression so that we can use the sample image expression to get the RGB values. It's basically going to run through, and if you look up here in the info panel, we're going to be getting any of the R values. And we're also going to say if the alpha is not there and there's no values, we don't want to read the pixels. So this is the expression we're going to be using. We're going to grab our alpha source text, and we're going to say .expression, and then we're going to say inside of this expression, our target layer is equal to this comp and our current layer name. So say we're on Galaxy 2 here, it's going to say our target layer is this Galaxy 2 layer. Our sample point is going to be an effect called point control, and we're going to be setting that up in just a second. But basically our point control is going to grab an area, and we're going to sample the radius and sample the colors and use these methods to basically get the RG or B or A values. In this case, A is going to be equal to math.round, and we're going to grab our sampled color and the third value, which RGBA is the third value. And then we're just going to say our output string is A, and we're going to do the same thing here with our red source text. But we're obviously going to change this a bit to red source text. We're going to keep the layer name here. And instead of A, we're going to say R for red is equal to math.round. Our output string needs to be R as well. And for the sampled color, if we look at RGB, R is going to be the 0th index. Alright, now we need to set up our point control still inside of our loop. So I'll say point control equals our current layer. We're going to go into the effects and add a property. This property's name is going to be Adobe Point Control. And then we'll set the point variable equal to our current layer. And now that we have our Adobe Point Control effects applied, we're going to go into our effects, grab the point control effect, and the point value. So if I apply a point control, you can see we have our point value here. And what we're basically going to be doing is going through here and reading some pixels. and averaging them out. Then I'm going to grab our these bounds variable, and I'll set this equal to a function called calculate bounds, and we're just going to pass through our current layer. Then we're going to say our shift is equal to calculate shift, and for this we're going to want to pass through our current layer these bounds, which we haven't gotten yet, but it's going to return basically the x and y positions we need. We're going to also pass through our red source text, our point, and our alpha source text. Then we're going to set the current layer to be a 3D layer. So we'll say current layer.3D layer equals true. And then we're going to grab our current layer and set the position property equal to shift. And when we calculate our shift, we're basically just going to return an x, y, and z array. And then after we do all this, we want to remove our text layers and effects. So I'll grab my red text and remove, grab my alpha text and remove, and then grab my point control effect, which is applied to our image, and remove. Alright, so the first thing we need to do is get our these bounds. So we need to go into our calculate bounds function. We start off by bringing in our current layer we're on. We're setting an empty array called bounds, and then we're going to set up variables for our mask and the path of that mask, which again is going to contain things like our vertices. And then again, we're setting up a variable for a factor, which just makes sure that if we have different sized images and compositions, everything is going to translate appropriately. So we're dividing our position, the x position, divided by the anchor point x position, and then two more arrays for temp x and temp y. Below this, I'm going to set a for loop so we can go through our vertices here. So I'll say var I is equal to 0, and for I is less than my path.vertices.length I++. So in this case, we have 1, 2, 3, 4, 5, 6, 7, 8 vertices. It's going to go through this 8 times. Now we're going to grab our temp x and temp y arrays, and we're going to push into them. And what we're going to push is simply going to be math.floor, so we want to round up a number here. And we're going to grab my path.vertices, and for the first one, index I 0 for the x, and then again my path.vertices, index I, and then 1 for y. And then just like up here, we had this custom function to sort out our array. Outside of our for loop, I'm going to go ahead and paste this and update these variables here. Temp y, temp x. And again, this is just going to set things from the lowest to highest value. Underneath here, we're going to set up a couple of variables, one called our first x, our last x, first y, and last y. This is basically going to be guessing the first x where we need to start analyzing, the last x where the width ends, and then the same for y going from the top to bottom. So because these two arrays have all of our x values and y values, we just need to grab the first one to get the first x and y, and the very last index to get the last ones. So for first x, I'll say temp x index 0, and then for last x, I'll say temp x, and then I'll grab temp x itself and its length -1. And same thing for our y, we'll grab our temp y index 0 for the first one, and temp y index temp y.length -1 for the last one. Finally, we need to set up our bounds array. So I'm just going to say bounds equals an array, which is going to have 4 values: our first x, our last x, first y, and our last y. And then it's going to return bounds here, and then set these bounds equal to our first x, last x, first y, and last y. So now we need to calculate our shift. Now that we have our bounds, we need to actually go through and analyze these things. So inside of our calculate shift function, we're bringing in our layer, our bounds, our source text, our point control, and our alpha source text. I should say our source text is our red source text. We have a variable called shift amount and these reds. And for these reds, we're just going to be adding all the reds together and then doing some math to average them out. So we're going to want to set up 2 for loops, one inside of the other here, which we're going to be using to go on the x-axis and y at the same time. So for the first one, I'll say var I is equal to the first x, which would be bounds index 0. So we're starting at the leftmost point. And we'll say for I is less than our bounds index 1, which is our last x, how far to the right we're going. Then we'll want to increment I, let's say by 5, so plus equals 5. Then for the second for loop, I'll create a variable e, which will be equal to our bounds index 2, or our first y, and we're going to go through this until we get to bounds 3, or the last y, and same thing, let's increment e by 5, because analyzing this pixel by pixel will take a long time with CPU power. So inside of here, we're first going to grab our point, which if you remember is just going to control where this pointer is and which pixels we're analyzing. So we'll say point.setValue, and we're simply inside of an array here going to say I comma e, which is our x and y. Then we're going to say if our alpha source text.value does not equal 0, and we also, because this is going to be text, not an integer, we need to parse the int, which will give us an integer instead of just text, so we can actually do math with it. So if this is not equal to 0, basically saying if it's not transparent, then it's probably a pixel we need to analyze, which means there's probably a galaxy there. We're going to say these reds.push, and we're going to push, again, parse the int, and we're going to grab our source text.value. So say we're on this pixel here, you can see up in the top right corner our R value is 135 and the alpha is not 0. So we're going to push into these reds 135 and we can continue going on to other pixels. Then outside of all of these for loops and if statements, we're going to grab our shift amount variable and set this equal to something. And what we're going to set this equal to is an x, a y, and a z value. So we can just apply our shift amount as a position. So for our x, we're going to say our layer and the position property. And we'll grab the value and the first value, which is going to be x. And then again, we'll grab our layer's position, the second value or the first value, which is y. And then for our z position, we're going to set up one more function here called shift to z position. And inside of here, we're going to pass through our array of reds, or these reds. And then finally, once we've calculated all this, we're going to return our shift amount, which will set our shift variable up here equal to an array of x, y, and z values, which will then be applied to our current layer. So we just need to finish our shift to z position function, as well as the one accompanying it, to finish up our Doppler here. So again, we're bringing in our red values array, which is going to be an array of values from 0 to 255, depending on the intensity of the redness. And the closer to 255 these are, the further away in z space we want them to be, and the lower they are, the closer we want them to be. So we have a variable for an average, a sum, and a counter to keep track of things here. The first thing we'll do is we'll say if our red values array dot length is greater than 0, so if we have found valid pixels to analyze, because remember if the alpha is 0, then we're not going to analyze those pixels because there's nothing there. So if the array is greater than 0, which means there have been some pixels we've taken a look at, we're going to do a for loop here. We'll say var I is equal to 0 and I is less than our red values array.length, increment I by 1. And for each time we go through this for loop, we're going to grab our sum and set it equal to parse int and our red values array index I. So it's going to start off at 0, then it's going to add our first red values array value to it and continue on. And we're also going to want to increment our counter every time in our for loop here. And then once we've calculated our sum, we need to grab our average. So we'll say average equals sum divided by counter, which anytime you calculate an average, you just add up all the numbers or sum them and then divide it by the frequency, or in this case, the counter number. All right, so if our red values array is greater than 0, then calculate our average. If it's not, if we don't have any valid red pixels that we've taken a look at, what we want to do is set our average equal to a random number. So I'm going to say math.floor and then math.random, And we want a random number between 1 and 255 or 0 and 255, which is the range of pixel values for each color. And the reason we're doing random is just so that we don't have any errors. If we had a super small galaxy and we were incrementing by 5 pixels and we skipped over all the useful areas, then we just need to do a random function to get a new average. Alright, and then we're just going to return RGB to Z position, and we're going to pass through an average. So we have a final function here called RGB to Z position, and the goal of this function is to convert RGB values to Z position. If you take a look at this image here, we need to calculate two different scales. We need to go from anywhere from 0 to 255 values up to a scale that has our min distance of 0 to a max distance of 10,000. So inside of our RGB to Z position, we're bringing in our average and calling it an input. And we're just going to write one line of code here. We're going to have a formula here. We're going to start with two parentheses. We're going to say input minus 0, which is basically input minus our input low, divided by 255 minus 0. So after that, we're going to divide our input minus our low divided by our input high and our input low. And then we're going to multiply all of this by our max distance minus our min distance plus our min distance. Now, I didn't come up with this algorithm myself. I found it on Stack Overflow, I believe. I'll post a link in the description below. But this will basically give us a conversion from two scales. We take our original input value, subtract it from our first scale's low, and then divide that by our first scale's high minus the low, multiplied by the difference of our new scale plus the min distance. Alright, so let's go ahead and run this script and see how it works here. And just to make sure that our anchor point is working, I'm going to grab a couple of these anchor points and just throw them way off. So first, I'll turn off our Doppler to do random, center our anchor points, and choose our bottom layer as our background. Click on Generate. And now if I rotate my camera, and you can see, we can start to zoom in and see that we have built-in Z depth, which is really cool, and we can just do a nice flyby. Now I can simply undo this a few times to get back to the original. And if I run my script again, I'll use Doppler this time, not center the anchor points, and again the bottom layer. And I'm also going to go ahead and delete some of these just so we can see it faster here. So we'll have 10 and click on Generate. You can see we have text appearing, and this is getting our R values as well as our alpha values and calculating all those pixels. And you might also notice that I have different sizes of galaxies, so the processing time can vary greatly depending on the size of your images. Alright, so now that we've finished, you can go ahead and again rotate our camera and start to zoom in to see that all of our galaxies are now displaced in Z space, and we can fly through them nicely. And they have a nice parallax with the background, which doesn't move as well. If you're curious how I made this nice little star background, it's really just a fractal noise with the colorama and a camera lens blur. So I just took a fractal noise and scaled it down to about 10, applied some colorama to make everything blue and yellowish, and then just blurred everything. Alright guys, that's going to do it for today's tutorial. I hope you enjoyed. This one was a lot of fun to make. If you enjoyed it, be sure to hit the thumbs up button if you've made it this far. If you have any questions or comments for future tutorials, be sure to leave those in the description down below. And of course, hit the subscribe button and the bell button next to it to be notified of when new videos are coming out. But again, I hope you guys enjoyed, and we'll see you next time.